Hello, welcome to a new virtual tour of the European Southern Observatory, also known as simply as ESO. Well, my name is Farid Char, and with the producer Felipe Zurita, we are going to be your guides on this journey to ESO's La Silla Observatory. And from my side, I am actually a guide of the Paraná Observatory for more than 10 years, and I have experience in astronomy outreach for more than 15 years, and I have been working in several projects in education and outreach. So I have some experience working on this subject, and also Felipe, of course, is has a lot of experience in astronomy outreach as well. So Felipe, how are you? Good morning.
Hi, everyone. I'm Felipe Zurita. I'm fine today. I feel little sick. Uh, I have a degree in astronomy and I love sharing science and astronomy with people. Today, I will be the producer for this tour online. Today is La Silla Observatory, and I am excited to help bring this experience to you. So let's go, Farid.
Okay, Felipe, thank you. So, ISO would like to join you doing with these virtual tours, taking astronomy directly to your home or wherever you are. So remember that you can send your questions or comments through this streaming. I imagine you might have some questions already. So for this purpose, you can leave your comments or questions in the comment section on Facebook or YouTube, and Felipe will collect your questions and comments and greetings, and we are going to talk about this during this virtual experience. Okay. Okay. So now we are going to start with this experience, and also please don't forget to share this experience if you enjoy it. You can share simply using your buttons for sharing on Facebook or YouTube. So now we are going to begin with this virtual experience, and I am going to start talking a little bit about the organization. I am going to talk about ESO. So in the next screen, you will see something important about the organization. Well, ESO is an intergovernmental organization comprising 16 member states. Its headquarters are in Germany, and Australia has recently joined as a strategic partner. Chile is the host state and home to all ESO observatories. Since the 60s, and with the purpose I mentioned, ESO chose one of the best places on the planet to carry out astronomy, the Atacama Desert in Chile. At that time, Chile had started a site exploration campaign to attract international observatories such as ESO to our country. So Chile offered land to, and ESO chose the area that seemed best. So ESO's mission in this case is to design, build, and operate astronomical observatories. And what for? To enable important scientific discoveries and foster cooperation in astronomy. Now, in the next picture, we are going to take a look at the observing sites in Chile. Okay, this is the picture. So, if you take a look, we can see some important astronomy sites. First, we have the Paranal Observatory. This observatory is home to the Very Large Telescope, or VLT, currently the most advanced visible light telescope on the planet. In the future, the Paranal Observatory will also host the Extremely Large Telescope, or ELT, which will become the world's largest visible light telescope. And we will also have the CTA, an array of telescopes for the detection of gamma rays. Then we have Chajnantor, the site where the ALMA and APEX radiotelescopes are located. ESO participates in these radio astronomical observatories with its international partners. And finally, we have La Silla Observatory, the site you will be visiting today. This was the first observatory built by ESO in Chile, 2,400 meters above sea level in the region of Coquimbo. We will go there virtually during the next hour. Okay, so let's travel to La Silla Observatory. Now, looking at our planet, we'll start our journey by land in Europe, since I must mention that ESO is a European organization. On this map, on this map, outlined in white, we can see the different ESO member states. Chile is the host country and home to all ESO observatories. To see the sites, we will travel to the Chilean mountain range. Now, as we move over the Atlantic Ocean, let me tell you more about ESO's mission. To give you an idea, ESO tries to devise which type of instruments are needed to study the universe, and then designs the pieces, builds and operates telescopes, responding to observational requests from around the world, and therefore encouraging cooperation in astronomy. Okay, we are almost there. We can see we are approaching to South America here, and we are almost arriving to the Atacama Desert. Okay, now we can see the mountains. We can see amazing mountains there. Now, can you see a mountain range with domes across? Look at the shape of this hill. Does it remind you of anything? Perhaps a horse saddle? In fact, the mountain itself and the observatory later were named after a saddle for horse riding. Now, over the years, ESO's La Silla Observatory has become the perfect viewpoint for studying the universe. Okay. Now, from the Earth, we can see that La Silla Observatory has many telescopes of different shapes and size. We can see the names of the different telescopes on the road, such as the ESO 1 meter Schmidt, as we can see there. We can see also the other telescopes, like such as the NTT there, and the CEST. This is a very old radio telescope, not in operations anymore. And the final side there is the ESO 3.6 meter telescope. Also, we have the Swiss 1.2 meters Tarot, the visitor center, as you can see there. And finally, the ESO 3.6 meter telescope. Okay. Now, again, in this case, La Silla was chosen by the astronomical community as an observational site at the beginning of the 60s. La Silla enjoys a large number of clear nights per year, a still and dry atmosphere, and dark skies, far away from artificial light sources, um, like light pollution. You know? Well, the observatory was officially inaugurated by ESO in 1969, and some of the telescopes seen on the picture before are now out of service. Currently, 10 telescopes are operating, and two are operated directly by ESO. The other telescopes, several of which are robotic, belong to other institutions with ESO providing facilities and support. Okay, so now we are going to take a look at the different telescopes. We have a view here of the mountain. We have a panoramic view of La Silla. So you can see we are in a very interesting location, and we have most of the telescopes there. And here we have the main telescopes we are going to visit in a few moments. This is the 3.6 and this is the NTT. Okay, so now from this viewpoint, you can see the ESO 3.6 meter telescope on your right and the NTT on your left. You will be able to appreciate the difference in their domes and the dimension of their enclosures, considering that the telescopes themselves are practically the same size. We will start by chronological order of inauguration. So we are going to visit first the ESO 3.6 meter telescope. Okay, so we are going to visit the telescope now. And here we are. Okay, so here we are inside of the ESO 3.6 meter telescope. or 360, as it is commonly named by the staff at La Silla. The name refers to the mirror's diameter. So back in the mid 70s, it was one of the largest telescopes on the planet. Currently, it hosts an exoplanet hunter. Its name is HARPS. This is a highly specialized instrument used every night to search for other worlds outside our solar system. What do you notice about the dome from the inside? Well, it's huge. The altitude from the first floor to the dome is 25 meters. The whole structure of the telescope is equal to a seven-story building. Now, everything seems very small here as compared with the telescope. For instance, can you see anyone over here? Let's take a moment. So maybe you can notice someone there. And yes, there is a person just there. We are going to take a closer look. So here we have a person. So this person is just below the blue structure. Okay, so this reference helps us to distinguish the telescope itself from the rest of the structure, which you will now see in detail. Okay, so we are going to come back here. Now, we are going to take a look at the details of this telescope. So for this purpose, I am going to open a picture. We will have a picture in a few moments. Okay, this is the picture. So you can see three things on the right side picture. First, in dark blue, we find the structure supporting the telescope itself. So basically, this is the mounting of the telescope. The mounting works as a huge arm supporting the telescope and includes several systems that provide power, such as electricity. On this arm, parallel to the Earth's rotation axis, the telescope moves to follow objects in the sky during the observations. Now, going upwards, in lighter blue, in this color, we have the telescope's body, which holds the 3.6 meter or 360 centimeters main mirror and the secondary mirror. So where is the main mirror? It is not visible because it's covered by its protection system, this black structure. This is a system of tabs which open and close to protect the mirror from dust or moisture while the telescope is resting. In the black tubular structure here, in the upper part, we have the secondary mirror, which gathers light from the main mirror in a beam and directs it to the instruments that analyze it. You will notice that the main mirror has a hole in the middle, right here. So the light is sent to the instruments through this hole. And where is the instrument? Well, the instrument, in this case HARPS, the exoplanet hunter, is not visible now because it is completely isolated in another room on another floor of this building. Now, the 360 began operations in 1977, and from the beginning, it represented a challenge for engineering and for ESO as an organization. European astronomy gathered talents from several countries to build an optical telescope in the 4-meter category, the largest and most advanced category that existed at this time. Now, why was such a large telescope needed? Well, in astronomy, objects are analyzed through this light. The more light we collect, the more we can learn. In this case, a bigger mirror will capture more light, and therefore, more information will be available. We will be able to see fainter objects and smaller details. Now, how do you think this giant telescope moves? We are going to take a look at a short video to know more about this. Felipe, will you
I have a question about 3.6. Are the 3.6 the bigger in La Silla? Yes, it is. This is the bigger telescope in La Silla. You say Farid is a category of 4 meters telescope. For that age, is the biggest in that decade. So yes, it is. The 3.6 is the bigger in La Silla. Remember, send your question, greetings, whenever, whatever you want to know about La Silla, telescope, astronomy, and let's go for it. Sorry for that pause.
It's okay. Thank you, Felipe. Thank you for your intervention with this question. So yeah, we will have more time to answer your other questions during this tour. So now, as I was explaining, well, a mirror for astronomy is not just any mirror, since its shape and surface must be perfect at the scale of fractions of thousands of millimeters. So to achieve this in the 1970s, an extremely thick mirror was manufactured, 53 centimeters thick on average. But this also implies an extremely heavy mirror. So the mirror weighs 11 tons. This is the equivalent of two African elephants. So if we want to build larger telescopes, we need to find other solutions. How was the next step taken? We will see it later with the NTT. So, Felipe, do we have any other questions so far before going to the NTT?
I have another question, but it's about the ELT, the next step of the telescope. Um, what will be possible with the LT? What is not possible with the BLT? The possibilities of the extremely large telescope is bigger than the
Oh,
BLT. Es-
yes. Do you want to answer or?
No, no, come on.
Okay, well, in my case, because I'm more familiar with VLT and some aspects of the ELT. Well, I can tell you that some of the important science of the future will be some very specific uh, analysis of exoplanets. For example, at this moment, we are able to detect exoplanets, and we can know some information about exoplanets. For example, the period of the orbit, maybe at an estimated temperature, the size, the density, this kind of details. But with the ELT, we will be able to detect something very specific. For example, the chemical composition of the atmosphere of an exoplanet. So this kind of specific details will be very important because you will be able to determine or estimate what kind of composition will have the atmosphere, and therefore maybe you can estimate a little bit better if the exoplanet is suitable for life. This kind of science will be possible with the ELT, for example, and this is not possible so far with the VLT. Okay.
Uh, and that is the one question. So remember posting your question in the chat box, and let's go to the next telescope. What is the next?
Okay, Felipe, thank you. So yeah, we are going to visit now other telescope. We are going to visit um, the NTT. So we are going to move out from the 3.6, and now we are going to um, continue with the next stop, the NTT telescope here. Okay, so I would like to highlight the differences between the, the 3.6 and the NTT. keep in mind that both telescopes have almost the same mirror diameter. So the NTT was inaugurated in 1989. It has a small and very compact octagonal dome with a system of flaps. This represented in its days an evolutionary leap in the construction of telescopes, since it allowed hosting instruments in smaller, lighter structures with improved airflow on the inside. Gone were the more classical and massive domes, such as the 360. I mean this one. Now, in fact, the flaps on the NTT enclosure allow air to flow smoothly, reducing turbulence and preserving the sharpness of the pictures. Okay, so now let's enter to the NTT. Okay, so here we are. We have two perspectives of the telescope. We are going to start here. So, do you remember the structure of the 360 telescope? Well, it's huge dome and hosts more or our colleague seen inside. Well, in this case, the building is practically attached to the telescope, and if we stand in front of it, we will look approximately this size. So we can see, for example, that this dome is more compact. You see, and here we can see a door, so you can estimate more or less the size of a person standing here. So in this case, the telescope mounting is also completely different. Here, the entire building spins around 360 degrees. Now, you can see the main mirror on a pale color round structure here. Okay? The disk is the mirror, and we can see that it reflects some light. We can see the mirror there. Okay? Do you remember the 53 centimeters thick mirror of the 360? Well, the NTT mirror has almost the same diameter as the 360. It's actually 3.58 meters to be precise, but it is significantly thinner. This mirror is only 24 centimeters thick. It is also much lighter, 6 tons. This is just one elephant. Okay, so to keep a perfect shape as the telescope moves, there is a system of actuators or pistons below the mirror. Um, the system is enclosed inside a box that you can see just below the mirror. We have 75 actuators going up and down to keep the perfect shape. This system is computer controlled and is called active optics. So the active optics was developed by ESO and represented a significant technology breakthrough in the construction of the next generation of telescopes in the 10-meter category. So active optics has been applied to all large modern telescopes, including the Very Large Telescope, or VLT, at Paranal Observatory, and the upcoming Extremely Large Telescope, or ELT, currently being built near Paranal in the Armazones mountain. We are going to take another look of this telescope from the other side. So you can see that it's very, very compact. The enclosure is very, very compact if you compare with the 360. Now, and where is the staff? Well, around 30 people work in La Silla on different telescopes and tasks. The scientific and technical staff work from the control room of La Silla Observatory, which is located in a building quite far from here. In order to understand better this, we have a short video to take a look at the scientists working from the control room in La Silla. Here we have the video. Please let me know, Felipe, is the left side for the 3.6 and the right side for the NTT?
sorry, I mute. In the left side is the entity control room, and the right part is a 3.6 control room.
Okay, thank you, Felipe. So yeah, we can see that this is mostly an office space, and we can see a lot of computers for different purposes, and we can see the scientists working there. We don't need a lot of people, and this is common in modern observatories. But we usually need a telescope operator and an astronomer. Okay, so this is more or less what happens during the night in the La Silla control room.
And now we have a video about the top 10 of the principal research and discover from ESO around the Paranal, La Silla, or different discover made with the astronomer work in ESO. So uh, let me take a video and starts, and later you can leave your questions wherever you want to know about at this point of the virtual visit. So let's go.
Observations with ESO telescopes have led to many breakthroughs in astronomy and, over the years, have been responsible for some truly remarkable findings. Here is our list of ESO's top 10 astronomical discoveries so far. Astronomers using ESO's Very Large Telescope have discovered by far the brightest galaxy yet found in the early universe, and found strong evidence that examples of the first generation of stars lurk within it, stars that were previously only theoretical. These massive, brilliant objects were the creators of the first heavy elements in history, elements that are necessary to forge the stars we see around us today, the planets that orbit them, and life as we know it. ESO telescopes have provided definitive proof that long gamma-ray bursts are linked with the climatic explosions of massive stars, therefore solving an enduring mystery. A telescope at La Silla was also able to observe the visible light from a short gamma-ray burst for the first time, showing that this family of objects most likely originates from colliding neutron stars. Astronomers using ESO's HARPS instrument in 2010 discovered a planetary system containing at least 5 planets orbiting the Sun-like star HD 10180. They also found evidence that 2 other planets may be present, one of which, if confirmed, would be among the lowest mass exoplanets ever found. Newer observations and reanalysis of the data suggest that there could be even more planets around this star. ESO's Very Large Telescope was used to detect carbon monoxide molecules in a remote galaxy, seen as it was 11 billion years ago, a feat that had remained elusive for 25 years. This allowed astronomers to obtain the most precise measurement of the cosmic temperature at such a remote epoch, and it matched the temperature predicted by the Big Bang theory. The atmosphere around a super-Earth exoplanet was analysed for the first time using the VLT. The planet, which is known as GJ1214b, was studied as it passed in front of its parent star, and some of the starlight filtered through the planet's atmosphere. The atmosphere was found to be either mostly water in the form of steam or dominated by thick clouds or haze. Using ESO's VLT, astronomers measured the age of the oldest star known in the Milky Way. At 13.2 billion years old, the star was born in the earliest era of star formation in the universe. Uranium was also detected in a Milky Way star and used as an independent estimate of the age of the galaxy. The VLT obtained the first ever image of a planet outside our solar system. The planet, which has a mass about 5 times that of Jupiter, orbits a failed star, a brown dwarf, at a distance of 55 times the average distance between the Earth and the Sun. In 2014, ALMA, the Atacama Large Millimeter Submillimeter Array, revealed remarkable details of a solar system that is forming. The images of HL Tauri were the sharpest ever made at sub-millimeter wavelengths. They show how forming planets are vacuuming up dust and gas in a protoplanetary disk. One of ESO's proudest moments came when 2 independent research teams, including ESO staff, arrived at a truly revolutionary finding: that the cosmos is not only expanding, but that it is doing so at an increasing rate. The findings of the separate teams were based on observations of exploding stars, or supernovae, including measurements made from ESO's telescopes at La Silla and Paranal. This discovery was rewarded with the 2011 Nobel Prize in Physics. And finally, several of ESO's flagship telescopes were used in a 20-year study to obtain the most detailed view ever of the surroundings of the monster lurking at the heart of our galaxy, a supermassive black hole. Astronomy is always moving forwards, and ESO's top 10 scientific discoveries are not set in stone.
Okay, very important, very interesting top 10. But we have an extra result, a sort of bonus track, and we are going to describe a little bit about this. So please, Felipe, do we have this additional video?
Yes, we have.
Okay, thank you. Well, in this case, this additional result is about something that happened in 2019. In 2019, a team of astronomers captured the first image of a black hole. The Event Horizon Telescope, or EHT, an array of 8 ground-based telescopes distributed across the planet, coordinated by an international collaboration, achieved the first direct visual evidence of a supermassive black hole. The picture reveals the black hole at the center of Messier 87, a massive galaxy in the nearby Virgo galaxy cluster. This black hole is 55 million light-years from Earth and has a mass of 6.5 billion times that of the Sun. Okay, so this is the picture. Well, I hope you enjoyed the top 10. The discoveries achieved by ESO, all the discoveries, of course, are truly amazing. So now we are going to change to another view, and we are going to take a look at the night sky, okay, from La Silla. So the night, as you can see, is beautiful from the observatory. There is no moon, so we can watch the night sky, and we can see a lot of different objects in this screen. So below, to the left of the NTT, we can see a very well-known constellation. Can you recognize it? It is right here. Well, this one is Orion, the Great Hunter, with its characteristic belt, also known in Spanish as Tres Marias or Three Marys. Okay. Well, in this case, tired perhaps after a long journey across the sky, Orion is ready to set over the western horizon. So as you can see, Orion is almost setting in the horizon. So in this case, we have a lot of other objects. We are going to talk about this. But let me also explain that this picture was probably taken in the probably in the in summer autumn. The hunter and the great dog that is with him, Canis Major, have been following a particular path through the sky, the Milky Way, our galaxy. So in this case, this star here is Sirius. This is the brightest star in the sky and belongs to a constellation called Canis Major. Okay, and as you can see here, this area has a lot of concentration of stars. So this is basically one of the arms of the Milky Way. Our galaxy is really a huge flattened disk with the shape as an spiral, but we see it as a band of light across the sky because of our viewpoint, since we are inside of this disk. So it consists of around 200 billion stars and huge clouds of interstellar gas and dust. We can see them later as dark clouds that cross the band of light. Okay? The red clouds, instead, are made of hydrogen, the simplest and most plentiful element in the universe, from which stars are formed. So we can see a nice panoramic view of this. Now, by looking through the Milky Way, we find two strange objects similar to clouds, and we can see those objects there, one here and one here. So, what is this? What is this? Well, in fact, these are the large and small Magellanic Clouds. This is the large Magellanic Cloud, and this is the small Magellanic Cloud. These are our closest neighboring galaxies, and at the same time, they are smaller than our Milky Way. This name, the Magellanic Clouds, is because of the first written record of their observation. Um, this observation was made by Ferdinand Magellan during the circumnavigation of the planet in the 16th century. And at this time, nobody knows actually what a galaxy is. So clearly, at that time, nobody knew what a galaxy was. So today, we know that galaxies are systems hosting tens of billions of stars, and that these are classified as irregular because of the shape. These typical objects of the southern sky also indicate the position of the south celestial pole. In this case, we can find this place, this south celestial pole, more or less like here, forming something like an let's say similar to an equilateral triangle. If you have this south celestial pole here, and in one corner we have one Magellanic Cloud, and in the other corner we have the other Magellanic Cloud. So here we can find something like a triangle, and this vortex is basically the south celestial pole. The south celestial pole is basically a projection of the south geographical pole in the sky. So this is why during the night the other stars appear to revolve around this point during the night. Okay, so but maybe the easiest way to locate the south celestial pole, and this is because in this hemisphere we don't have a bright star here, is using the Southern Cross, the constellation of the Southern Cross. The Southern Cross is located there. We can take a look here. This is the Southern Cross constellation. This is the smallest constellation in the sky. Okay, so basically, a good technique to find the south celestial pole is to project or to extend the longer stick. I mean, this one, the longer stick of the Southern Cross, 4.5 times. So let me try to do it. I will try to project this longer stick, about 4 times and a half. So it's 1, 2, 3, 4.5, and more or less like here, we have the South Celestial Pole. Okay? And so, as I told you before, during the night, the stars appear to revolve in a clockwise direction from east to west. Um, I say it seems because the Earth, of course, is actually rotating around the axis. Okay? Okay, so if we continue exploring our Milky Way, this will take us back to the 360. Behind this telescope, behind of the 360, we can see something interesting because here the center of our galaxy is rising, and you can recognize this by this, let's say, wider shape here, and the prominent dark clouds surrounding it. I mean, this, like this, like this. Okay, so in the center of our galaxy, we can find a huge black hole which has a mass of 4 million times the mass of our sun. Now, on the left side, you can see something like a colorful nebula here, and the dark filaments that surround the red supergiant star Antares. Okay, the brightest star is the constellation of Scorpius, an animal that in the mythology was sent to kill Orion. Okay, so there is a connection between Scorpius and Orion in the mythology. So basically, in the mythology, the same gods of the Olympus located them, Orion and Scorpius, in opposite places in the night sky. So that's why when Scorpius is in this side of the sky, rising, just in the opposite side, we have Orion. So they are always in the opposite directions in the sky. Okay. Okay. So if we know look at this region of the sky with the eyes of the native communities of the Andes, we will not look at the bright stars, but at the shapes of the impressive dark clouds, most notably the Great Llama. Its eye being the star Alpha Centauri, so basically is this one, okay, and so in fact this one, this star Alpha Centauri is actually three stars, but we see them as one, the closest to our sun. Okay. Okay, so something interesting about this sky, just to finish with this explanation, I want to show you something regarding this view from here, because there is something here that is very concerning. As you can see here, we can see some glares. We can see some light in the horizon here, here, and a very powerful glare here. This is actually light pollution. This is light pollution from nearby cities. So, Felipe, can you maybe help me? Can you tell me the city of
This
this
is
light?
the five root, and in the right side you can see the light of Vallenar City, and in the left part, near to 3.6, you can see the Coquimbo La Serena city light pollution in the other
Okay,
part.
thank you. Yes, this one, right?
Yes, this is the light pollution of Coquimbo La Serena. It's too big.
Yeah, that's right. So this is why it's so important to keep light pollution under control, because this is a problem affecting astronomical observatories. So okay, so this was an additional detail regarding this issue, because of course it's important to preserve the night skies in the Atacama Desert. Okay, so now we are going to move to another location because we are almost finishing this experience. We are going to move to this area because
Eh,
now we are going to follow the road to return to the La Silla Hotel because I am going to explain something else there to finish. You can see that in this road we have the other telescopes of La Silla. This road is connecting all the telescopes, and eventually we are going to reach the hotel here. This is La Silla Hotel. Okay, so in this case, we are going to relax now a little bit. This is the hotel of La Silla Observatory. Okay, now this person is the photographer who was in charge of contributing all those beautiful pictures for this virtual tour. So you can see that the galaxy, the Milky Way, is there in the sky. So the sky is very, very beautiful from any point of La Silla. And in this hotel, we have the staff. We have all the people working in La Silla. They are using this hotel um, for rest when they are not working. Okay, Felipe, I don't know if at this point we have some additional questions from the public.
Yes, we have a few questions. First is Dexter have a question about ALMA. Have 66 telescope and BLA have 27. How many telescope ESO have? Eh, One ESO in La Silla have how uh, organization ISO have in La Silla have three principal telescope, 3.6 ANTT and 2.2 German telescope. The other telescope you see in this tour is for particular countries. They also have a little part of that space uh, uh, for put on yours telescope. And in the BLT have a four telescope, right? And the other
Yes, yes, correct. In the VLT, we have four telescopes, the main telescopes of 8.2 meters. In addition, we have four additional auxiliary telescopes, 1.8 meters each. And we have two survey telescopes, the VST and Vista. So they are the main telescopes located in in Paraná. But we have other smaller telescopes for isolated projects. Now, in any case, this question is regarding the ALMA antennas. So yeah, so the ALMA antennas are 66, but let's remember that the ALMA is basically operating with three international partners, and one of the international partners is ESO. Okay, so we can consider the 66 ALMA antennas partially as part of the collaboration from ESO.
and we have a count of three for La Silla, four for BLT, and 67 for Alma. We have a amount of 73 approx
Yeah, it's a lot of
average.
telescopes.
This is average level of telescope. And the other question is a great question. Is there life in that universe than on our solar system? I hope find soon life in other place. This is a great question for astronomy. We have life in other parts? I think yes. I think yes.
Yeah,
Um,
so It's always an interesting question.
And hello, happy New Year's, everyone. That's right. This is the last visit guide, visit visit virtual guide for the year 2024. So we have no more question for today, and we have a new one. Where is light more far has been the BLTC, the BLTC, the light more far. I don't know what
Oh,
is the more far light see the BLT.
well, I think this is some kind of record or that is continually breaking up because um, I think one of the most far away objects is located at 13.5 billion light years from Earth. Um, but I'm not completely sure, but let's say that the most distant objects in the universe are probably galaxies because um, probably the earliest galaxies formed after the Big Bang. So when we talk about something so far away, like 13.5 billion light years away, we are talking about something that is very, very young because the universe probably has 13.7 million years. So um, probably this was one of the earliest galaxies in the universe. But still, it's important to mention that in order to observe such distant objects, it's necessary to do a very long exposure picture with the telescopes in order to collect as much light as possible. But yeah, probably something uh, is probably is a galaxy or group of galaxies located at 13.5 billion light years or something like that.
And this is the last question I have for this year. Thank you for your question, for your greetings, and this is all for today, right, Farid?
Yeah, so we are finishing here. I would like to remind you that all the visits, information, pictures, and material is available on the ESO website, um, ESO.org. So from my side, that's all. So thank you everyone for joining us on this virtual tour. And yeah, this is the last tour of the year. So happy New Year for to everyone, and I hope you enjoyed. And I hope to see you again in another virtual tour. It could be Paranal or La Silla, could be English or Spanish. So thank you very much, and thank you, Felipe, also for helping me as a producer today. So thank you very much.
And see you later. Bye bye.
Bye bye.